Good morning or afternoon, everyone. Thank you for joining today's webinar on closing the code coverage gap for distributed microservices. My name is Jamie Motherall, and I am Parasoft's Functional Solutions Product Marketing Manager. And on the line with us today, we have my colleague, Wilhelm Haker. Wilhelm, would you like to introduce yourself?
Yeah, hi. My name is Wilhelm Hocker, and I'm the Director of Solution Engineering for Functional Solutions here at Parasoft.
Wonderful. Well, let's dive on in. Give us just a minute and we'll share our screen and get started for you. All right. Well, today we have a great session planned for you that we're very excited about. We're going to be showing you how you can close the code coverage gap for distributed microservices, and we'll be discussing how you can leverage code coverage analytics to benefit your company and application teams. Now, before we dive in, just some quick housekeeping. If your view of the slides or the demo appears a little bit blurry, please be sure to adjust the video resolution in the BrightTalk window in your browser. And it helps if you can maximize the presentation to full screen. If you do have any questions or issues, please submit your comments in the Q&A area and one of our colleagues will reach out to assist. So let's start by going over today's agenda. We're going to start by discussing why just automating your testing practices is not enough if you want to truly optimize your quality assurance strategy. Then we'll go over why application teams and management should care about code coverage analytics. We will discuss agility in software development, technical benefits, and business benefits of code coverage analysis. Then we'll quickly touch on the barriers that application teams often encounter that halt their ability to benefit from code coverage initiatives. From there, we'll introduce our new code coverage capabilities that were recently released in Parasoft's 2023.2 functional testing solutions. And we'll take you through a technical demonstration of gathering code coverage from your testing of distributed microservices. Finally, we'll do a quick recap of the benefits and end with some time for questions. So if at any point throughout the presentation today you have a question, please feel free to just pop that into the questions section on BrightTalk, and we'll be sure to address it at the end of the webinar. So let's dive right in. Is test automation enough? At the end of the day, organizations usually are motivated to embrace test automation due to four primary business drivers. They want to increase their speed of delivery, increase the quality of their software, reduce software project costs, and reduce risks so that they can release with confidence. Best practices indicate that following Martin Fowler's testing pyramid is the most sustainable way to achieve these goals and create a scalable, maintainable test strategy, which is true. However, there are additional opportunities to optimize your testing practices and influence positive business outcomes when application teams take the time to analyze their testing practices, collect metrics, and leverage those metrics to create an environment of data driven decision making. Now, there are multiple metrics that can be gathered and leveraged to optimize testing strategies to accelerate time to market, increase quality, reduce costs, and reduce risk. Today, we'll be concentrating on code coverage and how these metrics can be easily gathered and leveraged to benefit application teams and business goals. However, if you want to see more of an overview on software quality metrics, I highly recommend watching our recorded webinar, Sprinting Through Software Development with Quality Metrics, that's on BrightTalk today on demand. We've provided the link to that on demand webinar under the BrightTalk resources and attachment sections in this presentation if anyone would like to take a look. Now, other metrics we recommend focusing on are requirements driven testing, which is essentially the tracking and correlating of your testing practices to your requirement tracking systems like Jira or Azure DevOps, as well as compliance and trends analysis. Now, this could be static analysis compliance or meeting specific code coverage requirements outlined by your organization. Again, today we'll be concentrating on the code coverage side and how to track and analyze code coverage and how that then enables data driven environments, decision environments that leads to testing optimizations and increases in testing efficiencies and velocity. Now, when you think of improvements to your testing practice, it's often beneficial to think about the cost of not doing something. So, let's take a moment to discuss the impact of unsuccessful code coverage initiatives or the ramifications of not collecting code coverage across your testing practices. At the end of the day, management wants to increase the speed of development, increase the quality of the software, reduce the cost of the projects, and reduce the risks associated with releases. However, the lack of code coverage visibility has a negative effect on each of these primary business drivers. Whether it's catching defects late in the process, fear of making code changes due to insufficient regression safety nets, having higher testing costs at scale, or having insufficient data to make decisions, these can all lead to negative impacts on your customer satisfaction and your bottom line. So, how does code coverage visibility reduce project costs? Well, untested code is risky code. Any changed code that hasn't been tested is untested code and is risky code. And when this code ends up in the hands of your customer, defects are more likely to be found. When defects are found post release, remediating the defects is time consuming and disrupting to developers who must become detectives to determine the root cause of the problem and how best to fix it. This impacts their development productivity as they're pulled away from writing new feature code to focus on remediation. The later a defect is found or a bug is found, the higher cost of the remediation. So, by releasing untested code into production, not only are organizations exposing themselves to risk to their brand name and to their customer satisfaction, but they're also increasing their software costs due to the high cost associated with remediation of these late stage defects. So let's get back to why track software quality metrics. When application teams use tools like Jira, GitHub, or Azure DevOps, they're balancing the team capacity with their workload of story points. But what isn't really factored into this equation is how to address things like quality, security, and resiliency concerns, and how that then impacts this balancing act regarding the agility of the team. This is really what you need. You need, in addition to these planning tools, a source of truth born from your quality metrics and allows you to leverage these metrics so you can balance quality with the agility of your teams. And that's where Parasoft really comes in. So let's break it down. Why measure code coverage? What can code coverage really do for you? Now, this question really depends upon your role in the development and testing of the application. Developers, for instance, often use code coverage metrics to identify areas of untested code that are high risk for bugs or defects. And by identifying coverage gaps, they can then determine if more testing is necessary to mitigate risks and release with confidence. Understanding what has not been tested allows them to easily and quickly create a strategy to prioritize what new test cases to create to close that coverage gap and mitigate the risk of untested code being released to production. For a test automation engineer, code coverage metrics can be used to analyze and measure the quality of their testing efforts across the broad range of tests they automate. When test cases can be correlated to what lines of code they touch, and then those metrics merged with all of the other testing efforts, such as unit testing, API testing, web UI testing, and end to end testing, test automation engineers can get a better sense of whether the application is truly release ready. Test automation engineers can also use code coverage metrics to speed up the feedback loop from regression testing and more quickly validate that code changes have not broken existing functionality. Code modifications can be correlated to the impacted test cases, enabling the execution of only the impacted test cases in their regression suite. Higher level functional testing, like web UI or end to end tests, can take a very long time to execute, which means application teams can reduce the size of their test suite that they need to execute to validate the impact of changes on their application and speed up that feedback loop. DevOps, also, DevOps engineers also benefit from successful code coverage practices. As executing these large regression test suites is time consuming, it's also consuming a large footprint of hardware resources. When the regression test suites are reduced and focused only on rerunning the test cases that correlate to code changes, DevOps engineers can free up these resources, allowing them to shift left and run more pipelines with shorter feedback loops that culminate in an altogether smarter DevOps process and practice that helps them to reduce their costs. Now that we've talked a little bit about the technical benefits, let's take a moment to look at the bigger picture and the benefits a good code coverage practice can provide that management really should care about. Decisions on if an application is ready for release need to be backed with data. Code coverage is a fantastic way to measure and to track to understand the overall health of your application and the level of risk it contains and if it is ready for release. Testing practices are also very costly in both manpower and engineering hours. When development teams that unit test blindly chase a code coverage metric, they often hit a threshold where they struggle to move past a certain percentage. Blindly creating more unit test cases is time consuming, and that often means that you're increasing your overall testing costs. When teams can see code coverage metrics associated with all of their automated testing practices, meeting specific metric requirements is much easier as they can easily see what areas of their code is untested and then make informed decisions on what type of test is needed to target that code and close that coverage gap. Application teams can further reduce the costs associated with their regression testing practices by reducing the size of the test suite they need to execute by focusing only on those test cases impacted by change. When your regression test suite is large with thousands of test cases, executing that test suite is time consuming because there's a maintenance and execution time factor that tends to lead to costly testing wait times as your developers and testers wait for feedback from the regression test runs. And it consumes hardware resources that drive up your cloud costs. By collecting code coverage across all of your testing practices and using code coverage data to inform the execution of your regression tests, management can reduce the overall cost of their testing practices. And at the end of the day, we really want to test to reduce risk. The risk of untested code making it into production and into the hands of your customers. Untested code is more prone to errors and defects. And when your customers experience bugs that negatively impact them, you're at risk of monetary losses by losing customer retention. Many companies also are mandated by compliance requirements to meet specific code coverage metrics due to the nature of their applications. Some organizations also simply enforce high internal standards for quality and use code coverage as a means to track the effectiveness of their testing strategy. Some organizations take it a step further where they advertise their high quality standards with marketing that builds trust with their customers. In either situation, gathering code coverage beyond just unit testing enables teams to more easily reach their code coverage metric goals, as well as higher levels of quality, making their customers happier. Attaining these higher levels of code coverage or application quality leads to higher customer satisfaction rates, which means for you, better reviews for your company and better customer retention and expansion. Happy customers leads to more customers and higher revenue for your organization. So there's a lot of benefits when it comes down to code coverage visibility that management should really care about. Now, a lot of coverage initiatives stall out or have limited impact because of the level of effort involved in both measuring the metric and applying the metric effectively. As we'll be showing you today, code coverage can be more than just a KPI you measure. We're going to explore exactly how you can achieve those business outcomes I was just covering using Parasoft solutions to break through the code coverage barriers that exist when you're using open source solutions today. So let's discuss what some of those barriers are. Some organizations don't measure code coverage at all, but many will measure code coverage from unit testing. This is easy to do, and it's a great way to start with the metric. However, organizations obviously do more than just unit testing. In fact, many organizations don't do enough unit testing and they more heavily invest in integration or end to end testing. For these types of tests, or in other words, black box tests, this is where measuring code coverage has some friction. It's doable, but now you're looking at a serious engagement engineering effort that developers don't want to invest time in because they have to build and maintain their engineering effort to collect these metrics. And they instead want to focus on new feature development. So teams often stick with only measuring unit test code coverage, which gives them an incomplete view of the testing taking place and ultimately limits the value of the code coverage metric. And then we have things like distributed systems architectures that make coverage collection even more difficult. Now, we're talking about a coordination of multiple deployments, all working together as an overall system that's being tested. With the prevalence of system level testing, that then means coordinating the measurement of code coverage from all of those microservices while your Selenium, Cypress, or Playwright tests are running. Needless to say, this friction goes from uncomfortable to a third degree rug burn. Microservices make the code coverage engineering problem much more difficult. So at this point, I'm going to turn it on over to my colleague, Wilhelm Haker, and he's going to start walking you through and introducing our solution for gathering code coverage from distributed microservices. Go ahead and take it away, Wilhelm.
All right, thank you, Jamie. So, when interviewing our customers about their code coverage landscapes, we heard some common themes that went into the development of our new offering. So, we heard that our customers use a wide variety of testing tools, and this makes measuring code coverage difficult because not many tools support code coverage out of the box like Parasoft's tools do. We also heard that at scale, it becomes very difficult to validate small changes because running a full regression test, even if it's automated, can take a long time to pass, right? Especially when tests fail and they're flaky and you have to rerun them. The sheer number of tests can become a problem. Also, at higher scales of testing, we heard that imprecise compromises get made to try to reduce that testing scope to be manageable within the bounds of Agile, right? For every single pull request, what do we do? For each sprint, what do we do, right? And there's certain scopes of testing that you want to reduce to fit that fast pace that may not be representative of the very thorough testing that would be done, let's say, for a release. And lastly, we heard that code coverage mandates are difficult to achieve with unit testing alone. So these are some of the reasons that we built this offering. And what we built here was the ability for an organization to measure code coverage from a distributed system and leverage that code coverage both for reporting and analytics, as well as test impact analysis, which I'll be describing in a moment. So before I show you the workflow here to measure code coverage from a running application, I think it's informative to first compare and contrast what it's like with unit testing. With unit testing, the test environment is simplified. And that's really one of the benefits of doing this type of test, right? So measuring code coverage here with unit testing is pretty easy and straightforward. However, when we're talking about a running application, things get more complicated. So first, we need to integrate with the build and deploy process so that a Parasoft coverage agent gets deployed with the application under test. And this coverage agent will expose an API that we're going to use while testing is taking place. And so next, we want to integrate also with your test framework. And so here, a Parasoft REST API is available to coordinate our code coverage workflow no matter what testing tool you are using. Right? So you no longer need to use Parasoft tools to get this benefit of code coverage. Now we're opening it up get the benefits of code coverage with any testing tool. And so to see the whole workflow in action, and when a test execution job gets run, so first we start a session, we start a test, stop the test, right? And for each test, we're telling our API start and stop. And once the session is done and all the tests have run, then we calculate the code coverage from those test runs and publish to our reporting server, DTP. And regardless of how many microservices you have in the test environment, whether it's 5 or 50, you can use our solution to individually measure code coverage from each microservice while you're running, let's say, a system level test, right? Your Selenium tests and those types of GUI-based tests. So we're measuring code coverage, and now let's look at how you can apply that code coverage for some of the things that Jamie was talking about around reducing costs and reducing the feedback loop. And so one way you can use code coverage here is what we call test impact analysis. And so it starts by having this mapping between each test case and what code gets covered, right? So we're doing more than just measuring overall code coverage while testing is happening, but we're individually measuring code coverage for each test case. And so next, when we analyze what code changed, right? Maybe this is you're baselining from the last successful build, or maybe you're baselining from the beginning of the sprint or the beginning of the release, right? You can baseline at different points to determine, okay, well, what's changed since that baseline? And with the mapping that we have, now it helps us inform which test cases should be run and which test cases should be skipped. And this can be automated, right? So the days of looking at your test plan and looking at the features that got developed and then manually deciding, okay, what tests should we run and what tests shouldn't we run? Now you can use code coverage to sort of automate that decision making, right? Only run the tests that need to be run and have it dynamically figure out what those tests are based on what code is changing in the builds. As we've been saying, this solution now also works for microservices. So it's no longer just a single application, but even with a distributed system, we have this capability. And a quick snapshot here before I jump out of the slides. To get a sense of what test impact analysis can mean, here on the left, we have a trend graph of one of our projects in-house where we run kind of a full regression, so over 4,000 tests. And on the right is where we enable test impact analysis, and we're only running tests based on what code changed for that particular pull request or that build. And you can see it's quite a big difference, right? There's a 0 missing in the y-axis. And so this has the implications of reducing the strain on your DevOps infrastructure because now you're not running so many tests all the time. And also the feedback loop to development, right? Waiting a whole day to come back the next day to see if your commits broke anything. That can be quite slow for Agile. And so getting that rapid feedback and having that feedback include more than just unit testing or smoke testing, but also include some higher level regression testing, system level tests or end-to-end tests. Now you get more fidelity, right, out of that check with each pull request. And we're not saying that, don't run the full regression with every test, but we're saying you don't have to run it as often as you need to, and there's ways to optimize. And so let's jump out of the slides here and I'll show you. Okay. So the demo app that we're using today, it's a Spring Pet Clinic. It's a Java Spring Boot microservices application. We forked the repo here And we've been using this for our demos for this new feature. And what I've been doing is I set up a little Jenkins pipeline where I'm kind of bringing the full gamut of Parasoft's capabilities to this repo. So also doing static analysis, unit testing, but really what we're here for today is to look at what we do around code coverage and how we integrate with the build, right? So there's when you package the application as part of the build process, those jar files or WAR files get built out. We want to hook into that part of the build. And then when you deploy the application in the test environment, even if that's a containerized deployment, you're using Kubernetes or OpenShift, our code coverage agents need to be deployed with those applications so that we can start measuring code coverage while they're running. And so I've got those things hooked up. I ran a redeploy of Pet Clinic here. And to give us a quick introduction to Pet Clinic, we've got some cute animals here. We've got some vets showing up. And so this app is up and running. And to show you guys that we're using containers here, Pet Clinic, it's actually running as Docker Compose in one of my AWS environments. So all these microservices are running in this environment. And we have our coverage agents here. So there's 4 services that we're measuring code coverage for. There's the API gateway, customers, vets, and visits. And so there's 4 code coverage agents here. And I can cycle through the ports here just to double check that they're all up and running, and looks like we're good to go. They're all up and running. So let's get started with what the Parasoft deployment looks like. And to start off, I want to introduce you to here Parasoft DTP. So here I have a dashboard that I built out. And as I mentioned, there's 4 of the microservices in this project that I've targeted to get code coverage for. And we have some portfolio reporting. So for each module, we're getting code coverage. We also do static analysis, test results, some analytics around the quality status. And then if we come further down here, I've set up some widgets for where each row represents one of those microservices. And here in DTP, right, these dashboards are fully customizable, so I can really draw this out however I like. And what we're seeing so far is I've got unit test coverage, but I don't have any functional test coverage yet because I haven't run them. And so this widget here that shows merged coverage, this is going to show us, okay, what happens once we run our UI tests? What is our overall coverage when we factor in both unit testing and functional testing together? Right, so this merged coverage widget will change as well. So this is the kind of the starting point for the reporting we have. We have some static analysis and unit tests, but we haven't done any functional testing yet. And so to get started with that, I also want to introduce you to Parasoft CTP here. And so this is your gateway to working with our code coverage solution, as well as integrating with your test framework. And what CTP can do, there's a number of things. It's a thin client for our service virtualization and API testing solutions. It has a test data component tied to those solutions. And then we have this environment manager. And what environment manager does is it lets you diagram out your environments and all the individual components that are representative in that environment where you're testing. And it's used for service virtualization workflows, being able to swap out between real service and virtual service, changing test data, things like that, kind of controlling your test environment on the fly. And what we added in this release is also the ability to manage the code coverage agents for your deployments. And what's nice is when you diagram this out, these details can be exported to a YAML or JSON file. And so as redeploys happen in your test environment, maybe there's a new build of a microservice, and you push that new build out into the QA environment. Well, we want to get updated of that new build, right? We want to know which microservices are changing when. And so rather than having someone come in here and manually update the diagram, this can be automated through one of our new REST APIs, right? Where you can publish these updates to CTP as part of your CI/CD scripts that run. And so each of our coverage agents we were looking at earlier, they're all set up and ready to go. I've got a particular build of Pet Clinic that we're testing. Each of the microservices has its own project here in DTP, as we saw earlier. So from the perspective of setting up, right, you can diagram it out once, export it out to JSON or YAML, and then continually keep the Parasoft diagram up to date by updating CTP automatically with your builds. So now that we've taken a look at that, let's jump in and look at some tests here. So here in Eclipse, I have some Selenium tests that I wrote for Pet Clinic, and this is using JUnit 5. But like we were saying earlier, you can use any test framework, any language of tests, or really whatever you want. Because we're integrating with the test framework through REST APIs, right? So if we look at this one here, pet test, for example, we can see that with JUnit, we've extended this test class with a Parasoft watcher that I wrote. And I'll run these tests while we explain what this watcher class does. So there's a number of API calls that you want to make with your test framework, like starting your connection to CTP, telling CTP when you're starting a test session. So that's an API call. We get a session ID that gets used throughout this workflow. And then at the end of all testing, we want to call some APIs at the end as well. So we set up a shutdown hook here. And then right before the test runs, each test runs, we want to tell CTP that this test is starting, right? So I'm getting the test ID from JUnit, and I'm filling that in with this API call to start test. And then for stop test, we've got successful and failed here. And so again, API calls that we're making to stop the test. And then lastly, once we're all done with every test, we want to tell CTP, hey, we're done testing, so stop the test session. And if we want to publish the results from this test session, we've got an API call for that. And then setting baselines is another thing, right? So as I was mentioning, if you want to compare from the last successful build, or if you want to compare from the beginning of the sprint or the release, then you can also set what those baselines are to reference them in the future. So pretty straightforward in terms of what API calls we need to make as a part of our test framework running. And so here we can see the tests are done, and now we're stopping our session with CTP, and CTP is collecting all the code coverage from the coverage agents and publishing results so that we can go see them in our reporting. So now if we come back to our dashboard here, what we will see is some new code coverage numbers. All right, so for API Gateway, for example, Our tests did quite good from a functional testing perspective. And so when we merge with unit tests, right, we get really, really good code coverage, right? And you can see these aren't really additive, right? We're merging what code coverage is overlapping between different testing types to give you that holistic overall view of how much code you're covering across all the testing that's being done. And so for each of our 4 microservices, we have this code coverage, and it's merging together where we can see some drill downs. Let's come to, let's say, vet resource. And I've got some, oh, let's find something that's a little more interesting to look at. Here, vet's a good one. So we can see quite clearly what code is being covered and not covered by our tests. And as I was saying earlier, right, we have that mapping between tests and code. And so when I'm looking at vet.java, I can see which specific test cases are contributing code coverage to this class, right? And that's going to give us that information. So when code changes, we know what tests to rerun. Which is what I'm kind of building us up towards right now. Let's say, okay, we've done our testing for this build, we're happy, we're good, but nothing is set in stone, right? Right? Developers are going to make some new commits, there's going to be a new build, and then we're going to have to kind of start all over. So let me show you, for example, in one of the classes here, pet request, I'm making a little code change here. And to save us some time, I'm going to run not a full build from Jenkins, but I'm just going to upload the reports from that code change to save us some time. Here, what I'm showing you is Parasoft SOA test. And this is just like in this demo, I'm using it as an API client, right? Basically calling REST APIs, looking at the JSON response coming back. SOA test happens to be our API testing solution that our customers use. The code coverage workflows that I'm describing in this webinar are built in with SOA test, but like I'm saying, you don't have to use SOA test necessarily. You can use any testing tool with our code coverage. I'm just using it here to make some API calls to sort of advance the story for us, where we now have a new build, and we should see these all come to zeros, right? So some code changed in each microservice. And so we have a new build, and obviously we haven't tested it yet. So, we have a bunch of zeros everywhere. And now we want to know, okay, well, what tests should I rerun, right? In the previous build, we had a handful. But in your environment, it's likely hundreds or thousands of tests, right? And for each build, it's that question, like, gosh, what do we do? Which test do we run? Maybe we just run all of them, but then that can be inefficient. So here we have an API to retrieve impacted tests. And so out of those 5-6 tests that I had, those Selenium tests that I ran, we can see that pet test and register owner and pet test, these are the 2 tests that were impacted. And that's how you can take this data, parameterize it with your test framework. So right, make a simple API call as a setup test or a setup action, retrieve the list of tests that you should rerun, and then only run those. And because this workflow we've built is API driven, you can really use it with any testing tool. Okay. And one last thing I'll mention before we wrap up here is our solution supports Java and .NET. So if you're wondering, our applications we're building, they're .NET microservices, that will be supported as well. in addition to what I've shown you today with Java. And also containerized deployments, something that I've shown today as well. And so containerization can make deployments tricky, right, in your test environments. A lot of organizations I'm working with, containerization is still pretty new, and they're getting used to it with their DevOps optimizations they're making. And so we've also been working to ensure that this will work well for those types of environments. All right, Jamie. So I'll hand it back over to you now.
Perfect. Well, Wilhelm, thank you for that technical demonstration. As you all just saw, Wilhelm was able to run test cases against the demo application's distributed microservices and easily gather code coverage that was merged and correlated with the existing unit test coverage metrics we already had for the project. This allows him to more easily meet any code coverage requirements he has and gives him the visibility he needs to ensure that come time for release, he can release with confidence, knowing exactly what has been tested across his project's microservices. We also saw that when Wilhelm's demo project had some code changes with a new build, he was able to call a REST API and retrieve exactly the list of impacted tests that should be rerun for those code changes in the new build, which he could then automate with his shift left pipelines and start reducing the feedback loop to development, along with the strain on DevOps infrastructures. Now, let's take a quick moment to recap the benefits. For developers, test engineers, and DevOps engineers, Parasoft makes it easier for code coverage to be gathered for analysis across complex systems, and it can be leveraged to optimize test strategies for better test coverage and efficiencies. For managers, code coverage analysis for microservices enables them to save time and allocate resources more effectively. It mitigates risks for addressing changes and coverage gaps, and they can reduce their time to market by speeding up that feedback loop to development through regression testing optimizations. Code coverage metrics gives them the visibility across a full portfolio of services and applications, enabling them to create that data-driven decision-making environment. And then finally, executives should also support code coverage initiatives as they lead to cost savings, such as higher quality software with fewer costly defects, making it into production and impacting your customers and your brand name, and then also helping you to deliver at a higher velocity. So at this point, I want to thank everybody for joining for today's webinar. If you do want to learn a little bit more about Parasoft Solutions, I highly recommend downloading the white paper you see there on Microservice Testing Strategies Guide. That QR code will take you right to there. If you'd also like to learn a little bit more about what analysts are saying about Parasoft, I recommend downloading the 2022 Forrester Wave. This was the most recent one that they did on continuous automation testing platforms. We also do have in the resources section that webinar I mentioned that talks a little bit more about different metrics and how you can leverage them to create higher efficiencies when it comes down to your test strategy. And I do want to take a few minutes for questions here. So let's take a peek at what we've got in the questions section. Let's see here. Okay, I do see a question. I know we covered this a little bit, but this probably came in at the beginning. Does this only work for test cases created with Parasoft tools? Wilhelm, do you want to address the questions?
Yes. So as we've been saying, it's really designed for any testing tool. So in Jamie's slide, she mentioned, right, Selenium, Cypress, Playwright. Pick your favorite testing tool. Now you can add code coverage and test impact analysis to that big picture of using metrics like code coverage effectively.
Mhm. And on the Parasoft side, really what you'll need there is going to be our CTP, continuous testing platform, and our DTP solution for reporting and analytics to help you gather those coverage metrics. I also see here a question about containerizing deployments with OpenShift. Do we work with OpenShift?
Yeah, yeah. You need to expose our coverage agent ports as part of the deployment. right? So for each microservice, to make that microservice accessible outside of OpenShift, which very often organizations do because the testing that they run isn't necessarily in OpenShift, right? So you need to expose it to outside of the cluster. And so, when you're exposing a port for the microservice, you want to expose an additional port for the coverage agent so that our coverage workflow will be able to communicate with those coverage agents. But yeah, we've been testing with containerization, and yeah, there shouldn't be any issues.
Fantastic. All right. Well, we have reached that 45-minute mark, which makes it the end of our presentation today. I do see there's a couple other questions in the chat, so we'll be following up with folks on that individually. But if you do have any questions, feel free to always reach out to Parasoft. You can email us at info@parasoft.com. I also recommend going to the Parasoft website, checking out our resources page. We have a lot of really great on-demand webinars. If you do want to learn a little bit more about microservices testing and how we're able to do API testing and help you to stabilize your environment against testing, I recommend taking a look at some of our webinars around testing for microservices as well. And again, we're always available for questions, or if you'd like to request a customized demonstration, you can do that on the Parasoft website, as well as in the attachment section here, we have included a link to our demo request page. Anyway, thank you everybody so much for your time today. We really appreciate it. And I hope you have a great day. And I hope you have a nice Thanksgiving coming up as well next week. Have a good one. Bye bye.